Clarification regarding Linus Pauling's electronegativity scale. We said that he basically came up with a scale where he assigned a value of 4.0 to fluorine and zero point 0.7 to francium based on bond dissociation energies. Exactly what does bond dissociation energy have to do with electronegativity? Well, what Pauling found was that if we had a reaction between H2 plus F2, that gives you 2HF. That reaction is exothermic. What that means is the energy needed to break the HH bond and the FF bond, okay? The average of the energy needed to break the H2 and the F2 bond, it turns out is less than the energy needed to break the two HF bonds, okay? So the difference, he attributed that difference, okay, to what we would call the ionic character of the HF bond. And so that, in a way, gives you a way of quantifying the concept of electronegativity. He said that the reason the HF bonds are harder to break is because of the ionic character in the bond. Okay, so based on that, he defined the difference in the electronegativity of the hydrogen and the fluorine as the square root of, so this is square root of the bond dissociation energy of HF, difference between the bond dissociation energy of HF and the average of the bond dissociation energy of H2 and F2. Now if you use, this is the unitless quantity where the bond dissociation energies that you plug in are in electron volts. Okay, so the experimental values for the bond dissociation energy of HF, H2, and F2 are 6.397 electron volts, 4.484 electron volts for H2, and 2.75 electron volts for F2. Okay, so if you plug in these numbers into this expression, you'll find that if you were to set, the difference is going to be 1.7, okay, between hydrogen and fluorine. Now, if you were to set the electronegativity of fluorine to 4.0, and then 4.0 minus 1.7, that would give hydrogen an electronegativity on 2.3. Now, based on various data, so he did not just rely on H2 and F2, he settled on the best possible values, and based on his original, based on his original work, Pauling came up with a value of 2.1 for H if fluorine was given an electronegativity value of 4.0. Okay, this EV to the negative 1/2 here, electron volts to the negative 1/2. That's just something you put in there so that the whole thing here, this whole expression comes out unitless. So electronegativity is a unitless quantity. Now, Allred and Pauling revised the electronegativity value of H to 2.2 in 1961 based on additional data. Now, there have been other scales that have been used to come up with electronegativities for atoms. One was done by Mulliken, and that one is based on the average of the ionization energy and the electron affinity. Now, Mulliken's scale can be scaled to match Pauling's value.